am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn about composite functions. Explicitly, I'll talk about domain of composite functions. In case you want to learn from me, you can always send an email on the address given. The question here is, find the largest domain of the following functions to be continuous. Let f of x equals to square root of x and g of x equals to x square minus 4. You need to find domain of f of x, g of x, g of f of x, and f of g of x, correct? Okay, so let's start answering this question. I hope that should not be very difficult. It is a good idea to sketch these functions just for understanding clearly how it works, right? So we'll just sketch the graph here. You can pause the video, answer the question, and then look into my suggestions. Square root x. As far as square root x is concerned, it is a function in quadrant 1, and you see that the domain and range is greater than or equal to x. G of x, which is the function I'm drawing next, x square minus 4 means a parabola opening up. If x is 0, the minimum value being 4, right? So that becomes the function. So clearly, we have to give the largest domain of the functions. So here the domain is what? We can write domain as equal to x belongs to real number. Let me just write them in interval notation. We'll say domain includes 0 and it extends till infinity, which is never included. Perfect. On the other hand, for question number 2, the minimum value here is minus 4. Since at x equals to 0, we have a turning point minus 4. However, the domain is all real numbers, right? So we write this as minus infinity to plus infinity. Only range is instructed in parabola, not the domain. So that becomes our answer. Now let's look into the composite function, right? So the main idea is to understand how do we figure out domain of the composite function. So let me first discuss g of f of x. G of f of x means what? It means g of the function f of x is square root x. You get the idea. So clearly, our domain is restricted to square root x, right? So as far as square root x is concerned, it is always positive. Now, g of x domain is all real numbers. And therefore, it should not really matter, right? So what do you get? Well, instead of x, I could now put absolute value of x to write down this particular function, right? So you can say the function really becomes what? Let me rewrite this as g of x is x square minus 4. So it becomes square root x whole square minus 4, right? X square square root. You know what this function is? This function is, let me write down once again, g of f of x is not x minus 4. It is equal to absolute value of x minus 4. You get the idea. That is the function we are talking about. And clearly, there is no restriction to the domain. if you look into g of f of x. However, at this instance, when we talked about, we know that inside function x is greater than equal to 0. And therefore, this restriction prevails, and we need to write here that x is greater than equal to 0. You get the idea. So for the first part, where inside function is f of x, which is restricted, the domain may not look like restricted. However, the inputs are restricted. Therefore, the domain of this function is from, we have to include 0, but till infinity. You get the idea. That is how we'll write domain of this function. And if you want to graph, how will it look like? Clearly, the graph of this function will be at x equals to 0, it is minus 4, and it is going to be 0 at 4, like this. The point here is included at minus 4, correct? So that is how we are going to sketch this function g of f. Perfect. Now let's look into the last example. I hope this concept is absolutely clear. So this domain is restricted by the inside function itself, which is square root of x. Now let's look into question 4. This time, f of g of x, right? Now we're looking into f of g of x, correct? So inside function is x square minus 4. So we're saying f of x square minus 4, correct? So that becomes the function which is equal to, if I put it within the square root, it is x square minus 4 square root. You get the idea. Now, as far as x square minus 4 is concerned, it has no restrictions at all. However, when we talk about square root of x square minus 4, we cannot have square root of a negative number, right? So how does this function look like? Well, clearly, we can also say x square minus 4 should be greater than equal to 0. And that gives you that x square is greater than equal to 4, or square root when we do, then absolute value of x is greater than equal to 2. So the domain of this function is what? Well, clearly, the domain of this function will be from minus infinity to minus 2 union 2 to infinity. You get the idea. So when I say absolute value of x is greater than 2, we are saying that on a number line where, let's say this is 0, then we are including 2 plus and minus 2, but we are going away from center. You see that point, right? So that is minus 2 and this is plus 2. And that is how we could give domain for question 4. So I hope this concept is absolutely clear. If you feel like learning from me, you can always send an email on the address given. Thanks for your time and all the best.